The James Webb Space Telescope, the most powerful space observatory of our time, has made a groundbreaking discovery. A colossal black hole weighing 400 million solar masses. This cosmic behemoth existed just 820 million years after the Big Bang, once again challenging our current understanding of how the early universe evolved. However, that's not the only surprise. Despite its rapid growth, this black hole appears to be consuming almost no matter at all. It seems the gravitational giant has entered a peculiar state of dormancy, a postprandial nap following an intense feeding frenzy. The mystery of supermassive black holes. Not all black holes are created equal. While the formation of stellar black holes, those resulting from the collapse of massive stars, is well understood, their vastly larger counterparts remain shrouded in mystery. It is now an accepted fact that nearly every galaxy harbors a supermassive black hole at its core, with masses ranging from millions to billions of solar masses. Contrary to their destructive reputation, these giants play a crucial role in galactic evolution and can be orbited by other celestial bodies in relatively stable configurations. However, recent research has confirmed that massive black holes, some weighing millions or even billions of solar masses, already existed a few 100 million years after the Big Bang. This discovery raises perplexing questions. How did these cosmic titans grow so enormous in such a short span of time? Where did they acquire the necessary matter to reach such sizes? These are the mysteries currently keeping astronomers on edge. One proposed explanation suggests that these black holes formed through the direct collapse of massive gas clouds or through a sequence of mergers. Another theory posits that young black holes somehow managed to surpass the Eddington limit, a theoretical threshold dictating the maximum rate at which a black hole can accrete matter. If this is true, these black holes may have either emerged as fully formed giants or experienced hyperactive growth phases interspersed with periods of dormancy. For the first time, researchers have identified a supermassive black hole that appears to follow this alternating pattern of intense feeding and prolonged inactivity. This remarkable discovery was made by astronomers Roberto Molino and Ignace Jad Ballis, who, with their team, pinpointed the object using the James Webb Telescope. A black hole. Unlike any other, the newfound black hole resides in a distant galaxy, designated GN 001-1830. Given that this galaxy existed just 800 million years after the universe's birth, its central black hole at 400 million solar masses is extraordinarily massive for such an early epoch. In fact, it ranks among the heaviest black holes detected from this cosmic era, comprising nearly half the total mass of its host galaxy. For comparison, in modern galaxies, supermassive black holes typically account for only 0.1% of their galaxy's total mass. Even the Milky Way's central black hole, Sagittarius A, weighs a comparatively modest 4.2 million solar masses. Given its sheer size, one would expect this newly discovered black hole to be an insatiable consumer of matter. Surprisingly, the opposite is true. Instead of actively growing, it is practically dormant, devouring 100 times less matter than expected for a black hole of its mass. Specifically, its accretion rate is only 0.02% of the Eddington limit, meaning it appears almost completely inactive. How can a 400 million solar mass black hole be starving? To unravel this mystery, scientists developed an astrophysical model exploring several potential scenarios. Their findings were unexpected. The black hole's existence could not be explained by conventional steady growth near the Eddington limit. Even the idea that it formed from the collapse of an exceptionally massive precursor failed to account for its observed characteristics. A more plausible explanation emerged, albeit one that initially seems paradoxical. According to this model, the black hole underwent a brief but extremely intense period of accretion before shifting into dormancy. These violent feeding episodes allowed it to reach its enormous size in the first place. Specifically, the model reconstruction suggests that for a period of 5 to 10 million years, the black hole devoured matter at a rate far exceeding the Eddington limit. This rapid growth enabled it to consume nearly all available matter in its vicinity. Once it exhausted its local supply, the black hole entered a kind of digestive sleep, accreting very little matter for an estimated 100 million years. This behavior may not be unique to this particular black hole. Researchers speculate that similar cycles of hyperactive growth, followed by dormancy, may have been common among the massive black holes of the early universe. However, confirming this pattern will require further discoveries. Since dormant black holes emit very little radiation, detecting them is extraordinarily difficult. The fact that scientists managed to find this one was a stroke of luck, possible only due to its extraordinary size. Another black hole, defying the laws of physics. While the first black hole appeared to lack an appetite, another recent discovery presents the exact opposite scenario. The James Webb Telescope has identified yet another black hole exhibiting an unprecedentedly high accretion rate, one that defies theoretical limitations. According to prevailing astrophysical models, a black hole's growth should be constrained by the Eddington limit. However, the newly discovered object, identified by experts from the National Optical Infrared Astronomy Research Laboratory, appears to have completely ignored this restriction. The case of LID 568, a black hole that shouldn't exist, researchers had been studying optically visible but X-ray bright galactic cores in the early universe. Spectroscopic data from the James Webb Telescope confirmed that these were dust-shrouded supermassive black holes. However, one particular object named LID 568 stood out from the rest. LID 568 existed less than 1.5 billion years after the Big Bang and displayed an astonishingly high accretion rate. Its X-ray brightness was 100 times greater than that of other observed early galactic cores, indicating an extreme feeding frenzy. Further analysis revealed an even more shocking discrepancy. While the black hole has a mass of about 7 million solar masses, its host galaxy weighs only 200 million solar masses, far too small to support such an active galactic nucleus. Additionally, astronomers detected an exceptionally strong outflow of hot gas around the black hole, suggesting a level of activity never seen before. The actual accretion rate of LID 568 exceeds the theoretical limit by a factor of 40. This means that in just a few million years, the black hole grew from a mere 100 solar masses to a staggering 7 million solar masses. This occurred during an era when the first galaxies were still forming, an impossibly rapid growth rate based on our current understanding. Breaking the Eddington limit, under normal circumstances, once a black hole's luminosity surpasses the Eddington limit, the resulting radiation pressure should push material away, self-regulating the accretion process. However, LID 568 appears to have bypassed this self-imposed restriction entirely. For the first time, scientists have definitive proof that super-Eddington accretion was a reality in the early universe. However, they suspect that such extreme feeding phases were temporary. If future discoveries confirm this hypothesis, LID 568 could be the missing piece in the puzzle of how the first massive black holes grew so quickly. Going forward, astronomers will continue searching for additional examples of super-Eddington accretion. Understanding how common these impossible growth rates were and how long they lasted may ultimately reshape our knowledge of black hole evolution in the early cosmos. And now, the decision is yours. How long will your click on the thumbs up and subscribe button last? Join our community today so you never miss a groundbreaking discovery. See you soon.